So, this morning or afternoon, depending on what hour you are in, we are going to start learning target 1.6, which is to describe the difference between accuracy and precision. And then there's a second part to that learning target, which is perform percent error calculations to determine the accuracy of an experiment if what's known as the theoretical and experimental values are known. So that's the learning target. Let's see what this is all about. So, first question in your guided question is, what is the difference between accuracy and precision? So here we go. The definition of accuracy is how close a measurement is to its true or accepted value. So, when you take a measurement in the lab, there's always going to be a little bit of error. It could depend on the piece of equipment that you're using. It could depend on how careful you're being. It could depend on some other environmental factors in the room, such as if there's a breeze blowing or something like that. But we want to know how close is that to what it should be, and that is known as its true, it's accepted. Sometimes it's called its theoretical value. So I'm going to go ahead and write that in as well. Okay, so a theoretical value, where would we find that? We could find that online. You just got to be careful that it is a reputable source. You could find that in a book. You could find that from your instructor. This is the best piece of data that you can get. Okay, so that's accuracy. I'm going to go ahead and highlight that, accuracy. Okay, so true, accepted, or theoretical measurement. Let's continue. Precision is how close a series of measurements are to each other. So in order to have a series of measurements, you have to have more than one. So you have to take several measurements in order to have precision. Accuracy, you only need one to see how accurate something is. But for precision, you have to have a series in order to tell if it's precise. So it's how close a series of measurements are to each other. Now, obviously, an ideal situation or an ideal lab data is going to have high accuracy and precision both. High accuracy and high precision. But that's not always the case, unfortunately. These bullseyes here kind of represent some different situations in the lab, or these targets, I guess. What we want to think of as the bullseye is our theoretical value. So what we should get. And all of our arrows are our measurements. And so if we look at situation number 1 here, where we have made 1, 2, 3, 4, 5 measurements, I want to talk about why this accuracy would be considered good. Now, if you look at them all kind of individually, we might only say that number 3 has any kind of decent accuracy. But if you look at them as a whole and you kind of average how far away they are from the center, as an average, these values are very accurate. So if we were to average those out, we would get somewhere close to the bullseye, or somewhere around the value that number 3 is. But as far as precision goes, it's not very good. They're sort of all over the place there. So I'm just going to write in here that because of the average makes that better in terms of accuracy. Now if you look at the second one there, we've got pretty good precision. There's 4 measurements in that target, so that we've got 4. 1, 2, 3, 4, and they're all really close together, But as a group, they are really far away from where they should be. So that's how we get poor accuracy, but good precision. And then obviously, that was situation number 2. In situation 3 here, we've got both good accuracy and good precision. So with these 4 measurements, they're all close together. As an average, they're very close to where they should be. Continue on here. Percent error. Percentage error and how it is calculated. You have to know those experimental and accepted true or theoretical values. So you have to know your measurement and the accepted true or theoretical value. You have to know those both. And we're going to do these kind of calculations a lot in lab, which is why I'm introducing them to you today. So when you're doing a percent error calculation, it's set up like this. Percent error is equal to the experimental minus the true, or the accepted, or the theoretical, and we're going to divide that value by the true value. And then we're going to multiply whatever we get for an answer there by 100 to get a percent. So experimental minus true divided by the true times 100. And to remember this, you have the true 2 times. True 2. It is the second value in your equation, and it shows up 2 times, both the top and the bottom. So true 2. True 2. Shows up second, shows up twice. So that is your percent error calculation. Ignore this. This is what we just talked about. So, here's an example problem for us to go through. It says you calculate the density of water to be 0.94 grams per milliliter. The true value is 1.0 grams per milliliter. What is your percent error? So remember, our equation is percent error is equal to our experimental value minus our true 2, divided by our true, times 100. So I see that we have 2 values here, 0.94 and 1.0, both densities. The problem says that you calculate it to be 0.94. The true value is 1.0. So what you calculate is less likely to be correct than the true value. So we're going to plug in for the experimental 0.94 grams per milliliter, and we're going to subtract 1.0 grams per milliliter. We're going to divide that by 1.0 grams per milliliter and multiply the whole thing by 100. Now when you subtract 0.94 minus 1.0, you actually get a negative number, negative 0.06 grams per milliliter. And we're going to divide that by 1.0 grams per milliliter. So we're just going to get the same thing, negative 0.06, and times by 100, that comes out to be negative 6%. So what does a negative percent error mean, and is that okay? The answer is yes. It's totally fine for you to get a negative percent error. We just did. All that a negative percent error means, a negative percent error just means that your measurement is lower than the true value. So however you calculated or measured, you were under. A positive percent error would just mean you were over. So it's not worse or better, it just means that you have a little more information about how you were off. And generally speaking, in this class, good accuracy is when you have 20% error or less. If you have more than 20% error, you usually have to do it again. There are exceptions. Okay, so let's see. That's it for now. So I have another set of practice problems for you guys to work on, and then we'll talk about it together tomorrow. Thanks. Hey.